Good afternoon, welcome back. This time I don't even have to introduce anyone because it's me speaking, finally. Who is actually speaking at the moment? I'm Massimo, I am the data science manager, lead machine learning engineer at Bumble. Why like these two roles? Because in the data science team at Bumble, we have some degree of a matrix kind of reporting lines so that I lead a cross-functional team in the trust and safety space in data science that employs data scientists, machine learning engineers, and machine learning scientists. And together, as a lead machine learning engineer, I have overall accountability for the MLOps infrastructure and all the people in the wider data science team that call themselves machine learning engineers. I am a computer engineer as training. I studied computer engineering, then I had an experience in data science, possibly even some data engineering, because when the company is small, the lines between data science and data engineering are quite blurred. And on a personal level, I have an interest in strong versus weak AI debate, consciousness, interpretability of machine learning models, and having this kind of debates on how an interpretable machine learning model is actually a useful machine learning model. But I spoke about this in the past, so you will find everything on my Medium, on my LinkedIn. I'm quite active on LinkedIn. You will find me there. Just to add a little bit of context, any of you is familiar with Bumble? Any of you heard about Bumble? Nice. Bumble Inc. Is the parent company that operates 4 different products: Badoo, Bumble for date, Bumble for friends, so BFF, and Fruits, that is a French app that was acquired in 2022. So as data science at Bumble Inc., we support all the products in our portfolio. And a little bit of an intro of what we're discussing today. The title is provoking, and there's no such thing as MLOps, despite today we are at the MLOps Summit and we heard a lot of interesting stories on how companies employ MLOps practices. I will try to give, let's say, an intro or my flavor of what I think is MLOps, and then first, career progressions in machine learning engineering and why I think that MLOps is not really a thing, is more of a term that the tech industry or the community made up, because at the end, people that end up working in machine learning engineering come from very diverse backgrounds. And then I want to give, let's say, an input on a framework for maturity levels in machine learning, because what I found around in the industry wasn't satisfactory, at least for my experience as machine learning engineer practitioner during the years. And then just as a deep dive, since at the end of the day is always what is more getting more questions is what is the stack that we are using at Bumble Inc. So I want to give you some insights on which is the stack that you're using at Bumble Inc. for possibly sharing some best practices. And why we're here, to some extent. I mean, we are here and the MLOps Summit exists because the MLOps term per se is getting a lot of traction. This is a very vanilla Google Trends that I put there 2 weeks ago. You can see that MLOps didn't exist until 2019, possibly, and then the community decided that MLOps was a term to discuss about, and now, I mean, was a I would say exponential growth to the today's. And what actually is MLOps? It's, let's say, said to have this talk at the end of the day, pretty much, because would have been possibly interested to have as the first talk. This is just the Wikipedia definition of MLOps. It's not something that you should read carefully at the moment, but some words here and there is the set of practices to deploy and maintain machine learning model in production reliably and efficiently, is the combination of machine learning and DevOps. And is indeed a term that has been created to, let's say, help data scientists to put machine learning models into production, but is not what DevOps people were doing for classical software engineering practices, right? This is indeed what is in theory, because then I want to give you a little bit of my insights on what actually is in practice, machine learning engineering and MLOps. And just to clarify and set the background for all the people here, what is DevOps is an historical term. I would argue that DevOps actually exists is a popular practice is in developing software at scale, in a sense that the engineer or the developers is the person that actually writes the code, again, oversimplifying at the extreme. But the developer is the person that actually writes the code. The DevOps person is the person that deals with everything else, that is putting the code that is running locally on your machine, and you've wrote the tests that are compiling locally, deploying them at a scale that possibly can be, I don't know, Google code base or even Bumble Inc. There is that Bumble Inc. products serve hundreds of millions of users worldwide. And I want to stress what MLOps is in practice based on my experience, and because I think that MLOps itself is much closer to DevOps. That's something that is completely new and a term that actually requires a new definition, possibly on Wikipedia. 3 pillars. The first one that has been stressed here and there during the talks that we had today, data scientists aren't always engineers. And when I say engineers, I say people, for example, that know how to use Git. Git is a tool that has been developed. I was checking while I was going down from the elevator in 2005. So it's 20 years of history, pretty much. And here is possibly introduced as the shiny thing that can improve the workload and the day-to-day operations of data scientists. So let's say that data scientists are indeed very good at math, statistics, model building, but to work in a tech company, to actually create tech products, you need engineers, or at least engineers, to facilitate the work of data scientists. And I think that when you are a machine learning engineer in a team in a decent scale, a lot of your time goes to actually evangelize the data scientists in actually employing best practices. The infrastructure can be messy because the reality is that building endpoint, an HTTP endpoint that is able to expose a model is an exercise that me and another talented engineer here can sort in possibly half an hour. The complexity is to actually putting a model to production doesn't mean just exposing the endpoint, but means creating an endpoint that is useful, let's say, going into an SLA framework and can integrate properly with messy legacy subsystems that needs to interact with this system. So you see that there is machine learning engineering indeed as a component of machine learning, but possibly the vast majority is also engineering, because speaking with other engineers require a lingo and requires understanding of an infrastructure. And in general, getting things done is hard. Like Agile, for example, it's something that has been built. If there are some Agile experts in the room, sorry for oversimplifying, but Agile has been built for making better and more efficient the way in which engineers ship their products. Engineering is around for 30 years, 40 years. There is plenty of literature on how to do engineering work efficiently, while data science in an industry is a job that doesn't have that literature. So I think that, in my experience, majority of the times what machine learning engineers bring in data science projects is literature on how to be pragmatic and efficiently ship stuff to production. What does a machine learning engineer do? A lot of things. First, starting from the one that I was already mentioning, on the top, legacy system understanding. I think that one of the most important aspects of a data science product is not the model training itself, despite, of course, it's a model, needs to be trained. I am biased, I'm an engineer. But you have to understand where this model is going to be deployed. Deploying a machine learning model to production is not deploying an HTTP endpoint that is actually able to accept requests. Is to actually design it in a way that is going to be useful for the use cases that are being envisioned. And you need an engineer for that, and goes together, of course, with solutions architecture, possibly data engineering to understand, okay, I mean, training a model, this obscure black box that data scientists are studying for our life to actually achieve, requires data, right? Is no news. It's like the truth of this decade, at least, that there's no data science without data engineering. Oftentimes, machine learning engineers are the people that can actually build this bridge between data engineers, that the more the data engineering practice is getting complex, the more there are more software developers building the data platform and communicating with the data scientists that indeed, going back, they are not people that are required to have in-depth technical knowledge. They possibly didn't even study computer science. So we need someone that translates. So machine learning engineers possibly as translators. Then, of course, there is coding, because something has to be coded. Despite, I mean, we watched a lot, we listen and watch a lot of talks where with GCP or SageMaker nowadays, you can indeed deploy an endpoint with just some clicks. But I would argue that to actually successfully deploy and build at scale and having decent communication with all the parties involved in very legacy and complex systems, there is a component of coding that cannot be eliminated. Best practices and pragmatism, that we go back to the topic that I was mentioning earlier. Engineers have 25, 30 years of experience in dealing with their own work. Data scientists are much, much more early stage on this. An engineering culture, an engineering mindset in data science teams can help a lot. And how to become a machine learning engineer, right? Because we were discussing about MLOps, I was arguing that MLOps doesn't exist per se. It's much, much more similar to what DevOps people do in, let's say, more classical legacy engineering teams. And I think that this is particularly relevant because doesn't exist an easy career progression to become a machine learning engineer. For becoming a data scientist, you can possibly get in as a junior data scientist. To become a software developer, there are plenty of internship, plenty of junior opportunities, because there is a lot of literature in how to become an efficient staff software engineer, how to become an efficient data scientist. There isn't that literature in how to become a machine learning engineer. And I think that we go back to the start. It's a complicated job. And if I have to speak to all the people in the room that have on their job title machine learning engineer, I would bet that if there are 20 people, 20 or at least 19 of them have diverse backgrounds and a diverse career history. The one that to me is the most frequent to see is ironically a pivot from data science. Let's say that it's what happened to me, despite I have an engineering background, so let's say that data science was already a pivot for me. They start working possibly in smaller companies that they don't have a lot of history in deploying machine learning models to production. They say, I have an amazing model that has been trained out of, I don't know, luck, a very good at architecture, very good at engineering team. I need to ship it to production, but I don't know anything about Docker, Kubernetes, HTTP, etc., etc. They upskill and they possibly become the first machine learning engineer in the company they're working for. The second one, there is another one that is particularly interesting, that is, and was mentioned probably in one of the talks earlier, someone that is a seasoned software engineer with a lot of history and experience in dealing with complex software systems that possibly starts interacting more often out of personal interest and personal studies, often after working hours, with data scientists that indeed are strong expertise out of academia possibly, with how to build data science models. They start to collaborate more often. The data scientist possibly becomes a machine learning engineer, but also the senior software engineer wants to become a machine learning engineer because, personal opinion, dealing with machine learning at the moment is one of the coolest jobs that you can have in tech. And so someone that possibly was used to build complex or possibly legacy backend systems has the appetite to migrate towards machine learning engineering. And then another one that is similar to the first one. I'm trying to be comprehensive, despite clearly I cannot in this anecdotal slide, but also data engineers oftentimes, when there are data scientists that build something and they don't know how to deploy it, tend to become more pivotal on machine learning engineering. I see it a little bit less likely because based on experience, data engineers tend to work more in silos in their data platform, and they have less visibility on the complexity of the architecture of the product they're working on. And so it's just, based on my experience, is less likely, but I might be completely wrong. And then when you reach the right level of maturity, when you have a functioning data science team, you have a functioning machine learning engineering team, then it's where this line starts to be created. That is, you hire junior machine learning engineers. Based on experience at Bumble Inc., we opened the first junior machine learning engineer position 2 months ago. We had a crazy amount of applicants, but because now, as the person, let's say, overall accountable for this strategy, I feel confident that we have something that is robust enough and mature enough that we can actually onboard someone that is junior and can get an impact based on their computer engineering skills, for example, while working in a infrastructure and in a team that is functioning. And I was mentioning maturity of machine learning engineering teams. Would be interesting for the room, or let's say for moving forward, how can we define when a machine learning engineering team is mature enough? right? How did I come up with the definition of, okay, my team at Bumble Inc. is mature enough, let's hire a junior, let's scale towards adding people and not skills. That is also another way of possibly phrasing it. At the moment in the industry, I found two well-known and used maturity models for machine learning engineering or MLOps. There are good things and bad things in both of them. And after this 5 minutes conversation, I'm coming up with another framework that I was putting together that resonate better with my experience and with the challenges that I think we had at Bumble Inc. and I see having fellow practitioners in the industry. The Microsoft Azure model is this one, is composed by 5 steps, goes from bottom to the top, no MLOps, DevOps but no MLOps, where DevOps but no MLOps, I was, of course, the slides should be synthetic, but I was reading different angles on how to explain this framework. DevOps and no MLOps is a proxy for saying we have a model and we just throw it over the fence to another team that is taking care of deployment, automated training, and then we have automated model deployment after the training step. That to me didn't make a lot of sense based on my experience where I would switch the two stuff. And then the full MLOps where we have full monitoring and zero downtime, while from my angle I would say, wait, having full monitoring should come even before having an automatic deployment process, because I can deploy whatever, but if I don't know how it's behaving in production, it's not going back to that engineering practices that have 20 years of literature. Monitoring is one of the foundations of having a successful engineering deployment, right? So it's fine. Let's say that I like the approach. I like the approach of trying to come up with a maturity model, but I wasn't completely resonating with the steps put there, and it's fairly complex. Then there is the Google Cloud model that, as Google usually does, is simpler and more around, let's say, foundations. 3 steps, not 5 as before. The level 0 is around manual process. You can also see that from left to right is also the traversing line is around automation. Manual processes, automated pipeline for training to serving, and then the last step that is self-serving and democratized access to infrastructure, no ad hoc pipelines design. I was listening to one of the talks that someone was mentioning Uber Michelangelo. I don't know if any of you is familiar, but this system, I think that is level 2 material, because a data scientist really doesn't have to have any in-depth engineering skills, because feature stores can be actually accessed from a UI. Everything is tidy, everything is collected. Possibly model can be trained from a UI, just selecting features and training an experiment. This is the level 2 level of maturity. I would argue that is not something that resonates with 99% of the companies in the world. I think that this level 2 of maturity is very utopistic, and it's something that not just is achieved by 4 or 5 companies, but I wouldn't even say that it is even desirable, in a sense that when I go to sleep at night and I think about the challenge that we have at Bumble Inc., it's not that having a fully self-serving and automated machine learning engineering platform is something that will change our life significantly. So the takeaways that I put together with these 2 models and all the others that I wanted to put in the slides is that the first step, ability to cover the models, is not covered. In a sense that if I have to speak with the statistics are out there, but if I have to speak to 70% of data science teams around the world, I think that they would wish to have an MLOps problem. They have a data science problem. They never ship anything to production for a lot of different challenges, while both Azure and Google are already assuming that there is a functioning data science team that is able to ship models to production efficiently for how much in a manual fashion. There is no reaction to change and drifts. And this goes together with the point that I was reading with Azure, in a sense that if full monitoring is the last step of the framework, how can you actually check how a model is behaving in production, right? And then the third step, that is the one that to me is crucial for every functioning MLOps or a machine learning engineering organization, is experiment replicability. And this goes together with Jupyter notebooks that don't go well with code versioning, in a sense that you might have an amazing model that is ready to be deployed in production, but you're not able to replicate the experiment. This is a huge red flag, in a sense that you have an amazing model, let's put it to production because it's the first win of the team possibly, but not being able to replicate the results that you're having is the biggest red flag. In a sense that experiment replicability should be the first step right after, okay, I shipped something to production, okay, but can I do it again? Not just can I do it again in another project, but can I do it again with the very same model that I already shipped to production should be the first step. So I put together this more realistic model that is composed by, let's say, 4 different steps with 2 things that can go in parallel. Just to give a brief explanation, maturity level -1. You never deployed anything as a team, and you see that is the one that is taking 30% of the space of this rectangle, because that's indeed, sadly, the vast majority of the data science teams around the world are struggling to deploy the first model into production. And then there is the first step, that is foundational machine learning engineering. Replicable training, and we go back to the topic that first thing, it shouldn't be automated, in a sense that we don't need to have a fancy CI/CD that triggers, runs. We need to have it replicable. Means that we are able to have same data set, same architecture, replicate the training, and reliable serving. And with reliable, we have fully observable as a first thing, and then possibly easy to be served. And then in parallel, 2 aspects, and I tend to agree with the guy at King that I don't know if he's still here, that was mentioning that feature store shouldn't be the first thing that you have to build. Fully agree. Data access goes as the 3rd step when you already sorted out the first 2 steps. Possibly feature storage, experiment replicability with an UI. So for example, experiment tracking, ClearML, Comet, weight and biases, MLflow, you name it, I tried them all. And time to production, because with a feature storage, what you actually end up improving is the time to production. And on the side, service performance. For example, having educated opinions over CPU versus GPU inference is the next big thing and goes together with cloud consumption, possibly with sustainability of the whole aspect. I don't know if in this room there is an expert on this topic, but inferencing on GPU is not always the right approach. It's not that throwing compute to a model where inferencing is the answer to all the problems that you have in machine learning. And then ability to serve multiple frameworks. There are a lot of details. Might be that you are amazing in deploying tens of models, but then you have a machine learning expert that comes and wants to use PyTorch and you don't know how to serve it. A level of maturity is being able to give me whatever, I'm able to deploy it in the same fashion. And then the full maturity scale is, to me, the ability to react to changes, despite concept drift from my experience. It's something that is so specific to the task and the problem you are trying to solve that it's very hard to fit it in a framework. But of course, having something that is able to automatically or semi-automatically react to changes, it's the full level of maturity. Then self-serving, as Microsoft Azure is pointing out, is a nice to have. But when you have everything here, is already an amazing outcome. Then, just for the sake of time, because I want to leave time for questions, how do you achieve these things? Some tooling here and there that is not supposed to be comprehensive, but the full maturity. Kubernetes is an amazing foundational tool, is a huge complication to what you have in your stack, but allows, if well implemented, to have for free pretty much everything that you need for running an effective MLOps infrastructure. Kubeflow is king on top of Kubernetes, in a sense that the 2 goes together, but it's better to have a Kubernetes cluster per se and then putting Kubeflow on top than, oh, I want Kubeflow and then I need Kubernetes. It's just a level of maturity, so you have Kubernetes no matter what. And then you have Kubeflow, and everything else that Kubeflow is not able to solve can go directly to raw Kubernetes. Kubeflow for free gives you Kserve and Jupyter Notebooks. And just a note on Jupyter Notebooks, the crazy good thing of Kubeflow is that Jupyter Notebooks are accessible with a unique URL. So storing Jupyter Notebooks or versioning them might not be needed for sharing them. And it goes to the bigger topic of how do you keep working with Jupyter Notebooks and actually utilize what they're good at without destroying completely a GitHub repository. Been there, done that. Then some ideas for the next 2 steps. On the side of experiment replicability, I tried them all. The tool that I like the most, personal opinion, is ClearML, open source tool. We can discuss later. It's open source, so it doesn't cost anything. You can deploy it on-prem, as all the features that you would expect from an experiment replicability framework. Feast for feature storage is something that we are actively experimenting on. And on the other side, Kserve, that is included in Kubeflow, gives you for free a lot of monitoring and logging capabilities. And then we have, of course, the usual stuff with Grafana and the logging gestion, et cetera, et cetera. Then, just to wrap up, perfect in time to give you some time for asking questions if you have any. 3 learning, like take-home points that I want to give from these, let's say, provoking title. Good machine engineers are not unicorns, in a sense that in the industry we tend to think that a machine engineer should be the person that owns the end-to-end, that is able to ship a model from conception to production. This is kind of true. You cannot expect them to also be NLP researchers, right? This is kind of true, but I think that an effective machine engineering team is a team that is able to have, on the inside, different backgrounds. So people that come from data science, people that come from possibly DevOps, so they are experts in running a Kubernetes cluster with an interest in machine learning, and then junior machine engineers or people that come from software engineering is a diverse, a mix of diverse backgrounds that actually gives the best in a machine engineering team. Every context is different. Again, I'm giving here some things as they were truth, is my experience. Every context is different, and since machine learning engineering practice is very context dependent and is very stack dependent, there isn't a recipe that works for everyone. And the last one, that is one of the most important ones, despite in the industry there is a lot of tendency to ship fast and give results very quickly, and GCP, like with Vertex AI and SageMaker, moving it in this direction, and maybe that some teams need to go fast with fully managed solutions. I think that in data science, at least, slow and steady progress and slow and steady iteration is the key for long-term success. And this is it. Perfectly on time.